Hi everyone, I am Dr. R. Soumya, Assistant Professor, Department of Electronics and Communication Engineering. In this video, we are going to see about local search optimization problems and adversarial search. Objective: to understand the concept of local search optimization problems and also to understand the concept of adversarial search. Let us see the local search and optimization problems. Here, hill climb algorithm is used in the artificial intelligence. Hill climbing algorithm is a local search algorithm which continuously moves in the direction of increasing evaluation value to find the peak of the mountain or best solution to the problem. It determines when it reaches a peak value where no neighbor has a higher value. Hill climbing algorithm is a technique which is used for optimizing the mathematical problems. Features of hill climbing. The following features are designed for the hill climbing algorithm. First, generate and test variant. Hill climbing is the variant of generate and test method. The generate and test method produce feedback which helps to decide which directions to move in the search space. Greedy approach. Hill climbing algorithm search moves in the direction which optimize the cost. No backtracking. It does not backtrack the search space as it does not remember the previous state. State space diagram for hill climbing. The state space landscape is a graphical representation of hill climbing algorithm which is shown a graph between various states of algorithm and objective functions, cost, etc. On y-axis, we have taken the functions which can be objective function or cost function and state space on the x-axis. If the function of y-axis is the cost, then goal of the search is to find the global minimum and local minimum. If your function of y-axis is objective function, then goal of the search is to find the global maximum and local to find the global maximum, and this is the graph. Different regions is present in the state space landscape in this, that is shown in this graph. Local maximum. Local maximum is the state which is better than its neighbor state, but there is also another state which is higher than it. That is represented in local maximum. Next, global maximum. Global maximum is the best possible state of the state space landscape. It has the highest value of the objective function. Current state. It is the state in a landscape diagram where an agent is currently present. Float local minimum. It is a flat space in the landscape where all the neighbor state of the current state have a same value. Shoulder. It is a plateau region which has an unfilled edge. Types of hill climbing algorithm. There are three types: simple hill climbing, steeper ascent hill climbing, stochastic hill climbing. First one is the simple hill climbing. Simple hill climbing is the simplest way to implement a hill climbing algorithm. It only evaluates the neighboring node state at a time and select the first one which optimizes the current state and set it as the current state. It only checks its one successor state, and if it finds better than the current state, then move else be in the same state. Features of the skill climbing: less time consuming, less optimal solutions, and solution is not guaranteed. Algorithm. Step 1, evaluate the initial state. If it is goal state, then return success and stop. Step 2 is the loop until a solution is found or there is no new operator left to apply. Step 3 is to select and apply an operator to the current state. Step 4, check the new state. Here, if it is goal state, then return success and quit. Else, if it is the better than the current state, then assign a new state as a current state. Else, if not better than the current state, then return to the step 2. Step 5 is exist. Steepest ascent hill state. The steepest ascent algorithm is a variation of simple hill climbing algorithm. This algorithm examines all the neighbors node of the current state and they select one neighborhood node which is close to the goal state. This algorithm consumes more time as it searches for multiple neighbors. Algorithm for steepest ascent hill climbing. Step 1. Evaluate the initial state. If it is goal state, then return success and stop, else make current state as initial state. Step 2. Look until a solution is found or the current state does not change. Let SUCC be the state such that any successor of the current state will be better than it for each operator that applies to the current state. Here, first apply a new operator and guarantee a new state. Evaluate the new state. If it is a goal state, then return it and quit, else compare it to the SUCC. If it is better than the SUCC, then set new state as SUCC. If SUCC is better than the current state, then set a current state to the SUCC. Step at the last step is the exist. Third one, stochastic hill climbing. Here it does not examine for all its neighbor before moving. Rather, this search algorithm select one neighbor node at random and decides whether to choose it as current state or examine the another state. Thank you.